Matplotlib is a Python-based plotting library with full support for 2D and limited support for 3D graphics. It's written in Python and it uses NumPy and other extension code to provide good performance. It's widely used in the Python scientific computing community. With Pandas, we can use Matplotlib directly to produce charts and plots from our data frames. Matplotlib is not part of the Python standard library. We need to download it and install it. Let's do that next. By now, I believe we can all install Python packages in our sleep. We go to Preferences, click on Project Interpreter, click on the plus sign, and here we want to install Matplotlib. We verify the version and then click on Install Package. It may take a couple of minutes. And the package was installed successfully. Please go ahead and download the following files from the Canvas course site. Plotted.py, that's a skeleton module that we'll use. pypl.csv, iris.csv, and top30.csv are some datasets that we'll use in our demo. We'll start with the pypl file. This CSV file is based on the information available at the pypl website. PYPL, I believe I mentioned it before, stands for Popularity of Programming Language. And this is the current ranking of the programming languages as of April 2020. So I took this table here and I created a CSV file based on it. And we're going to load that CSV file and plot the data with Matplotlib. Let's go to our plotted module and visualize the pypl data. We first import Matplotlib pyplot. We rename it as PLT so that we have less typing to do. The data is loaded in the dflang data frame. The language is the index. So let's start with a pie chart. Pie charts are the best. We use the pie function. We'll plot the share column and let's see what we get. We got nothing, there's no error, but the chart is not displayed. To display the chart, we need to call the matplotlib show function. And now here's our chart. It's a beautiful pie chart, but not very useful. We have no idea what these colors mean. Let's fix that by adding labels. We'll use our data frame index, the language, as our labels here. Let's see what we get. And we got labels, but we got way too many of them. So we have too many slices for the pie chart to be useful. Let's fix that by focusing on the top languages only. We'll take a slice that goes from Python, the top language, to R. And we're only interested in the share column here. Now we get a pie chart of the top languages only. We'll use the explode argument to offset the top language for a nice effect. And here's what we get. You can see that Python is at an offset, and then we only have the 7 top languages and they are all labeled. That's a much better pie chart. The colors in the pie chart were chosen for us, but we can also pick our own colors. The color abbreviations are mostly as expected. B is for blue, G is for green, R is for red, except for black. Since we can't have B for black and for blue, the abbreviation for black is K. Now, instead of a pie chart, let's create a bar chart. We use the bar function. Here we need to specify the values to be used for our x-axis. We specify our index values for that. And we also need to specify the values used for our y-axis. So that's going to be our top language series. Let's specify our own colors here. So we'll use the color argument and we'll pass it an array of colors. We could have spelled out the colors. I have used the abbreviations here. And here's our bar chart. On the x-axis, we have the language names. These were taken from the index of the top language series. On the y-axis, we have the values from the share column. The colors of the bars correspond to the colors we specified in our color array. The first one is cyan, the second one is magenta, and so on. Our chart needs some labels for the x-axis and the y-axis. So let's go ahead and add those. We also need a title for the chart. Here we go. And let's try to run our module now. And here's our chart with the X label, the Y label, and the title.